So E says the position of a bug moving up and down a vertical post is given by that equation. Find velocity of 3. So I'm going to show you how to do this first by hand. Hopefully we can get it done by hand. And then I'm going to show you on the calculator, even though this doesn't say it's a calculator. So we should be able to do this by hand. So Y of t is the position. This thing is position. And so velocity, we're supposed to know. We're supposed to know that this is position and velocity is the derivative of this. So you need to tell me that you know the derivative of position is equal to velocity. So we're going to do the derivative of this thing right here with respect to t. So this negative 12 over pi is a coefficient. So I leave it negative 12 over pi because that's a number. I do the derivative of cosine, which is negative sine. Leave the angle the same. Let's see, that's pi t over 6. And then chain rule says do the derivative of the angle last. So the derivative of pi t over 6 is pi over 6. And then the derivative of 6t is 6, and the derivative of negative 1 is 0. So I'm going to simplify this thing. So let's see, that pi and that pi reduce out to 1. That 6 and that 12 will reduce that to negative 2. So this is going to be 2, because negative times negative is positive, 2 sine pi over 6t plus 6. And that is my v of t. So now I am supposed to plug in here 3. So I'm going to plug a 3 in. And I'm going to plug a 3 in. So what that means is I am getting 2 sine of pi over 2 plus 6. Well, pi over 2 on the unit circle is way up here at the top where the ordered pair is 0, 1. That's pi over 2. So the y sine's the y value, so it's 1. So this is going to be 2 plus 6, which is 8. So that should be the answer, 8. So you go to the front of the top page and mark off 8 because that's not it. I forgot to close the parentheses. I don't know what parenthesis. Oh, this parenthesis right there. Okay, thank you. You're right. I should have closed that parenthesis with that one. Does anybody else have any they want to see? Anything else? Big 10, practice tests, problem you don't know how to do? Come on, people, give it to me. Oh, F. We're going to do F. E, F, and I probably don't have that up there. Oh, I do. Good for me. Although this is in the way. Okay, I can see it, I think, well enough. Okay, particle is moving along the x-axis. The position and velocity of the particle is recorded at various times in this table up here. At which time is the particle moving towards the origin? Okay, so here's some things you need to know that we haven't talked a whole lot about. I'm not even really sure if we have. If v of t is less than 0, now this is talking about moving along the x-axis. So this is talking right or left. So if velocity is less than 0, that means the object is moving to the left. If the velocity is greater than 0, that means the object is moving to the right. And if the velocity equals 0, that means the object is stopped. So we need to see, let's see, the position, velocity, particle at various times. At which time is the particle moving towards the origin? Okay, so this thing says, so this is my x of t, and this is my t. This says at time t equals 1, the object is at 3. So actually, maybe I should change this because we're talking about it crawling on the x-axis. So let's call this time 0. That's time 1, time 2. I'm sorry, these are actually x values. We're going to call this the x-axis. So what this tells me is at time 1, the object is at 3. So we're starting right here is where the object is. Then at time 2, in 2 seconds, the object's at 0. So if the object is here at 3, and it goes to 0 at 2, that means the object's moving left. Okay, then it says at time 4, the object is moving, it's going to be at -1. At time 6, the object is at -4. And then at time 8, the object, so from time 6 to 4, the object is going to be way out here at 8. Nope, sorry, 5. I looked at the wrong number. The object's going to be at 5. Okay, so that means the object is going this way. Now, this stuff down here is telling me at the exact time of 1, the object's moving right and moving right. That's what these mean. This means moving left. This is moving right, moving left. So this thing is, we don't know what's happening from 1.1 to 1.999. We don't know what's happening from time 2 to 3.999. We don't know what's happening from 4 to 4.10001 to 5.999 and so forth. So the only time we actually know what's happening in it is because of these velocity things. And since the only one that gives me a velocity less than 0, this one means that we want this answer to be time of 4. So we actually don't even need to do this number line thing. Okay, so that should be 4. So go back to the front page, mark off number 4. What else do you want to see? Anybody else got anything? Practice test, Big 10, don't care. Anything. If you guys don't give me any more to do, we're going to call it a day. I'm going to remind you again on Monday, we're going to do review. So if you find some questions you have over the weekend, number 5, we're going to do number 5 on the practice test. But if you find questions on the weekend, you're going to Zoom Monday, 4th period, and then you're going to ask me for help. So we're going to do number 5 on the practice test. So let's go back and see if we can find number 5, 11. Okay, so 5's up there, and I can't see it very well. Looks like to me, well, somebody verify this because I got a thing on my screen and won't let me see it. Does it say d2y over dx squared? Is it one second derivative? Is that correct?
Yes.
All right, so we got to do the second derivative of this problem. So we are going to do implicit differentiation here. Now, I was thinking that I already did this problem, so let me look. Because I wrote it down on my sheet. I did do number 5. So number 5, I'm going to show you where you can find it on my Canvas page. So here's my Canvas page for this week. And you want practice test. Here's practice test. There's 2, 5, and 21. So if you go to Wednesday, click right there. There's going to be number 5. And here's this is practice test 7 and 25 AB, practice test 15, all of them. Here's the ones I did today in second period. So you can go watch that video. Does anybody else have any they want to see? Now, if you watch that video and don't get it again on Monday, you can ask me and say, hey, I watched the video and don't get it. Would you explain it some more? And you can do that anytime you watch videos and don't get something. Come in and ask me questions. I love the why questions. The whys are the best. Somebody tell me, give me another question. You got nothing?
Can you do number 9 on the practice test?
Number 9 on the practice test. We can. All right, so number 9, is wanting just the first derivative. So let me get this thing off the screen here. Come on, pen. All right, so we were supposed to do the derivative of this thing. So it says y equals negative 4e to the secant of x. So you're supposed to know that a derivative, first of all, your coefficient's negative 4, so it just stays right there. And then we got to do the derivative of e of secant t. So when you do have an e to a power, you write the exact same e to the power down. And now we have to go and do the derivative of the secant. Well, the derivative of secant is secant tangent. And there's my answer. So that would be dy dt. Because my variable's t, that means we are doing dy dt on this one, not dx. Does anybody else have any? Okay, I'm going to assume you got it down. So if you have any other questions, be ready to ask them on Monday. Have a great weekend. Stay out of trouble. Do what's right, not what's popular. And I will see you all on Monday.